This is a second video over the exam in statistics for chapter 7 and 8. In this section, I will cover the questions relating to hypothesis testing. The first question is just pretty much a general question. You're given a scenario. In this case, let's say that the World Health Organization found that 29% of the children under 5 in Bangladesh suffer from wasting in 2005. Then a new study in 2009 shows that 41% of this age group suffered from wasting. Okay, so we're going to use null hypothesis testing, or at least we're going to set it up to determine if the new result is statistically significantly different from the old one. So the first question is, what is the a priori assumption? A priori assumptions are those that are held prior to beginning the test. In this case, it was 29. Because you said, it was determined in 2005, and that is your assumption going into the test. So the null hypothesis says nothing changes. It says the mean is still 29%, even though you got a different value. It wasn't statistically different enough to warrant changing or stating that the mean is actually different than what it was before. The alternative hypothesis in this case, now this depends on how you write it. You could write it as that the mean is actually greater than 29, since the 41 was greater than 29. If you write it like that, it is then a right-tail test. Also, you could have written like this, that it simply was not equal to 29. Whoops, ran out of room there. If you write it with a not equal to sign, then it would be a two-tail test. So depending on how you answer C, you're going to write either right-tailed test or two-tailed test or left-tailed. Let me review what that is. If the alternative hypothesis has a not equal to sign, then it's a two-tailed test. If the alternative hypothesis is written as mu is greater than some value, the a priori value, then it is a right-tailed test. If it's written as mu is less than some value, than the a priori value, of course, then it's a left-tailed test. So it depends on how you answer C. It could be, it doesn't matter how you answer C, but then D has to agree with how you answered C. In the next question, you have to fill in one of these 2x2 charts showing the correct decision and the type 1 error and type 2 errors. In the 2x2 chart for hypothesis testing, we'll put a column here. First column, the null hypothesis is actually true. In the second column, the null hypothesis is actually false. In this case, we have a null hypothesis that the patient is sick. So the first column means the patient really is sick. And this one would mean the patient is healthy, or at least not sick of that particular disease. Then we go down here and we have lab tests. The lab test could come back negative or it can come back positive. Now if it comes back negative for a sick patient, you've made a type 1 error. The sick patient was declared well when indeed they were not. But if the test came back negative and the person was healthy, that would be the correct decision. Now for a positive test, if the test is positive and the person is sick, that would be a correct decision. But if the test is positive and the person was not sick with that disease, that would be a type 2 error. In a type 2 error, the healthy patient is declared sick. Okay. Generally, the type 1 error is the one that one tries not to make. And the type 1 error means that you're rejecting a null hypothesis that really was true. But sometimes, especially in medicine, this might not be true, that the type 1 error is worse than the type 2 error. So here's a scenario, and you can make a decision there. Let us say the disease is not life-threatening, but the treatments for the disease are terrible. They're debilitating. They have many side effects. In this case, a type 2 error would be worse because you would declare a healthy person sick, and the person would have to undergo some terrible treatments. So in this case, a type 2 error would be worse. Since the disease itself is not life-threatening, the fact that the healthy person wasn't declared sick probably, well, it won't kill him anyway. Now, for a very contagious disease, you would not want to declare a sick person well and turn them back into the community in order to spread the disease. Now, in this question, you do actually a sort of a hypothesis testing, although you don't have to do much of a calculation at all. There's be a blank graph, and on that graph you need to mark the left tails for the probability of 90%, 95%, and 99%. Okay, so to find those values, you go to the reference section. This is the information for the hypothesis testing. You'll see the H0 and the H1, so you should be able to recognize it. Then there's all three types of tests are listed. The two-tailed test. Remember, for the two-tailed test, the alternative hypothesis has a not equal sign. For the left-tailed test, it has a less than sign, and for the right-tailed test, has a greater than sign. Okay, but you'll be told what it is. In this case, it was a left-tailed test, and you need to draw the tails and mark the critical values for 90% probability of making a type 1 error, 95%, or 99%. The only calculation you have to do here is to remember what alpha is. For alpha, the percentage of taking the type 1 error is written in decimals subtracted from 100. So you have 1 minus 0.90, and it's 0.10. So that's your alpha value, and you can see that right here. For the 0.95, it's 1 minus 0.95, giving you 0.05 for an alpha value. That's in the second row, and for 0.99 or 99%, its alpha value is 0.01. Connected with each value of alpha are critical values. So a critical value for alpha equal to 0.10, which corresponds to the 90% probability of making a type 1 error. That critical value is minus 1.28. For the 95%, it's minus 1.65. And for the 99%, it's minus 2.33. So you take that information back to the graph. Now here were those three values, minus 2.33, minus 1.65, and minus 1.28 from the reference section. Those values are noted here, here, and here. Like I said, in the sample exam, the written sample exam, if you're fairly clever, you could shade all these in a different way and have them overlap. Then you're given a z-test value of minus 2. Draw in the z-test value of minus 2, and that's what's drawn in right here. Now the question is, when will the null hypothesis be rejected? Right? If you want to make 99% sure that you don't make a type 1 error, that would correspond to the critical value of minus 2.33. The 2 is greater than that. The 2 is in the non-critical region. Therefore, for this value, the way this particular situation is set up, you would not reject the null hypothesis. For the other two, you can see that the minus 2 lies to the left of it. It would lie in their critical regions. So in these cases, you would reject it. So that's all the calculation that you have to do for the hypothesis testing. In fact, that's the end of the exam. So everything's in the reference section. Study the reference section in the sample exam so you're familiar with it and you can go to it and use it. And the questions are going to be very similar to the ones that you see here on the sample exam.